Good morning, ma'am. My name is Rajveer Kalsi, and I am here to present you with my digital assignment 1, which is on the topic Advanced Encryption Standards. So let's dive into it. In this presentation, we will discuss about uh, cryptography, block ciphers, AES, and its architectures. So, what is cryptography? Cryptography is a technique that is used to secure information and communication through the sources of codes or keys that for the people those who wanted to secure their data or information from others and understand it and process it. It has several features such as confidentiality. That means that the data is being secured privately and its privacy is maintained. And then integrity means that the data is not being modified by any other third party personnel or an attacker, and the data that is meant to be received by the receiver is only being received. Non-repudiation means that there is a contract or a record of the communication between the sender and the receiver. And authentication means that only the people who are authorized to take a part in the communication or take a part in the modification of the data can only take part in it. So only the authorized people can modify or send or have any contact with the data. Now, the cryptography has two parts, has two types. The first is symmetric key in cryptography, which means that there's only one key involved in the encryption and decryption of messages. It is very fast compared to other cryptography methods, and AES and AES are two of the most popular systems that uses uh, symmetric key cryptography. And the second type is asymmetric key cryptography, which means that a pair of keys are involved in encryption and decryption process, which are private key and public key. The public key is used for encryption and the private key is used for decryption. The public key is being shared by between everyone in the world, whereas the private key is just kept with the sender and the receiver. And the most popular cryptography system that uses this type of cryptography methods is RSA algorithm. Now, before we dive into what is AES, we need to know about what is a block cipher. A block cipher is an algorithm that takes a fixed size of input, say B size, and produces a cipher text of B bits again. If the input is larger than B bytes, it will be divided further. So suppose that the input size is very big than the intentional block size, then those bits will be converted into smaller bits of data or information, and then those bits will be ciphered. So let's understand this with a architecture diagram. So as you can see here, suppose P is a sender and C is a receiver. So P sends the data through encryption, which goes through an encryption process where a key is involved and function is being ORed to it, and only a block size of the input is being taken and then given to the receiver. So the discussion also takes place the same way, and in block size of the input is converted into blocks, and those blocks are being decrypted, and then uh, the the decrypted text is being received. So now that we understood what is block cipher, let's dive into what is AES. AES was introduced to the world on the year 2001 by International Institute of Standards and Technology. This AES is widely used today as it is much stronger than DES and triple DES despite of being harder to implement. Uh, Due to the old standards that were used in DES, it was very easy for the attackers to decrypt it or to attack the system. So AES was introduced by the international standards. So its features are that AES is itself is a block cipher, which, as we understood with the previous example, with the previous slide, that how the block cipher works, and it is a symmetric block cipher system. So it involves one key only. So the key size can vary from 128 bits, 192 bits, and 256 bits. And the encrypted data of blocks are 128 bits only. So basically, AES has three different types: AES 128, AES 192, and AES 256, depending on the what size of the key is being used. So now let's understand AES better within architecture. So as you can see, there is a plain text of 128 bits, and this plain text is being converted into a matrix which is of size 4 by 4, and the 4 by 4 matrix is being um, given to an initial transformation which we will learn about in the future slides, and then again those bits are given to a round key around a series of round consists of a series of um, permutations and substitution network which the text or the input state goes through, and by a series of rounds the input text is being converted into a cipher text. So as you can see here, the round is given as n minus 1 to till round n. This is for to show that the last round of the encryption process will consist of three transformations, which we will learn about in the future slide. So rest of the rounds consist of the four transformations that the plain text will go through. And you can see the size of the key is given as m, which is just to show that text of a key of m bytes will be used, and the key expansion will convert this key to 16 bytes, which is again 128 bits. So in each round, and as well as in the initial transformation, 128 bits of key will be used to transform the plain text into a cipher text. So as you can see, if the length of the um, key is 16, as it is shown here, the number of rounds will be around 10. So there will be four transformations in up to 9 round, and in the 10th round there will be 11 third three transformations, as well as if there are 24 bytes of keys used, then 12 rounds will be there, and 32 will be for 14 rounds, which is AES 128, AES 192, and AES 256. So AES also use a Festal cipher, which is a very old cipher, with the first one of the first ciphers that was introduced, and it uses substitution and permutation network to. It comprises of the series of linked operations, some of which involves replacing, which is substitution, and shuffling of bits, which is permutation. So we will know more about in the first few further slides. So this is the input and output slates as we saw here. The plain text is transformed into a matrix. So this is how it is done. So the input is converted into a matrix like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it in the initial transformation, it may be substituted with different keys, one by one. So this input has been converted into as 0 0. So this is done when this key is being implemented in the initial transformation. So a new output will be formed. This is for the encryption process, this left side, and the right side is for the decryption process. Same key will be used in both of the occasions. Now key expansion. So here, as we saw, that there are m keys which is converted into a matrix of m size, m into m size. So this key of m into m size, which is in this case is 16, so which is 4 into 4. So these keys will be divided into 43 different 44 different words, and which these words will be used in the transformation series, in the transformation and in the rounds, and these words will be XORed with the inputted data and used as keys to encrypt the data or to decrypt the data. We will understand it further with more examples. So as you can see here, the round consists of four transformations. The first round, as we talked about earlier. So the first key, the four transformations are substitute bytes, shift rows, mix columns, and add round key, which we will learn about one by one. So firstly, the words from 0 to 3, there are each word consists of 4 bytes. So 16 bytes are taken, which is 4 words, and is the key is implemented to add round key stage of the round, and these are further pushed to the next round. So firstly, let's understood what is substitute bytes. So let's understand with a example, with a diagram. Um, this is substitute bytes. So suppose this is the input key, that input metric that is received by the round. So it will take any one byte from the round, and it will generate an x and y value, which will be given to an s box. So s box is a fixed 16 input bytes of matrix, which will which looks like this. So suppose the x value is 7 and the y value is 7. So that input value where the x value is 7 and y value is 7 will be replaced by this f7. So this value where the value is 7 7, x value 7 and y value 7, this will be replaced by the value f7 f5, and placed it in that position only. So this is substitute byte transformation, where the bytes are being substituted with the help of s box. So yes, after that we have shift rows, which looks like this. So in shift rows, which comes after substitute bytes, the substituted bytes in the form of matrix are taken, and the first row is not being shifted and not touched at all, and it is kept as same as it is, and the second row is taken and is being permutated in this fashion. The first bit, the first byte is taken and shift to the last portion, and the last portion is taken to the third, similarly to the second and to the first portion. So in this way, the permutation takes place for the second row with one byte position to the left, and the third row is taken and shifted to the two positions to the left. So this is taken and shift to the two position back to the left, and this is taken to the left. Similarly, this is taken, if you see like this, 1 2, this is 2, and this is 1 to this place, and the last row is taken, which is and substitute the right side, third three positions to the left. Every row is being pushed left or shifted in the left side. So this is shifted to the three positions, is which one, two, three. So this is position to the third side, the third three position to the left, and similarly this is position to one, two, three. So from here to here. Similarly, this is shifted to this, and this is shifted to this. So this in this way, shift row occurs, and the rows are being shifted. So after this, we have mixed column where this uh, matrix is taken and multiplied with another column, which can be any column of mathematical function, which can be any mathematical functions, which consist of 4 into 4 matrix, and this matrix is being multiplied with this to get a result which is mapped into another matrix. This is mixed column, just a simple multiplication. And at last we have round key. So in the round key, the whole column is being taken and XORed with the word, which is generated by the key expansion as we saw earlier. And these words are being XORed by the column, and a separate value of the data is being introduced. So now that we understood all of that, the as we saw, the last round of any AES architecture will not consist of one transformation, which is mixed column. Yes, and in the this is for the decryption encryption process. Now for the decryption process, the whole thing will be reversed, and the first round will start at the end, and the number of words will also be reversed. So the from 40 to 43. So 41, 40, 41, 42, 43. These words will be taken at the beginning, and the 0 to 3 words will be taken at the end to get the plain text. Similarly, here the round 10th key will not have the mixed column at its round. So this is another architecture to understand the whole flow. As you can see, the state is taken and substituted, and then again shifted, the mixed columns, and then XORed with the key or the words to get the final state. So we saw all of this. Now, decryption process, as I told you, is a reverse of the whole encryption process, and it consists of the similar features, but the order of the feature is being reversed. So AES is one of the most widely adopted and supported by both hardware and software. And till date, no practical attacks against AES has been discovered. Additionally, AES has been built flexibly for key length, which allows a degree of future proofing against progress in the ability to transform exhaustion key searches. So the brute force attack is also not applicable for AES. And yes, it's a very good system. So thank you for the opportunity to present my knowledge about AES to you, and I hope that you like my presentation. Thank you, ma'am.